So what we're going to do is we're going to look at break-even analysis from a graphical point of view. We're going to see these variables on a graph, and we're going to look for where on the graph indicates the break-even point of the firm. Okay, and if you've ever heard the phrase break-even point, it comes from a graphical representation of break-even analysis. Now, before I can talk about, before we jump into what break-even analysis looks like from a graphical point of view, I want to introduce you to two types of coordinate planes that we use in microeconomics. Okay, and really the only difference between the two is the label for the vertical axis. Okay, this graph that has quantity produced and sold on the horizontal axis, but just a dollar sign on the vertical axis, this is the total dollars graph. Okay, this represents the total amount of dollars, like total revenue is going to be represented here, and total cost, and fixed cost, because fixed cost is basically the same thing as total fixed cost, and then variable cost is also a total. Okay, and so these are what we typically see on the total dollars graph. Okay, but over here, the more common, the one we use more frequently in microeconomics is the dollars per unit graph. Do you see up here on the vertical axis, instead of just a dollar sign, we have dollar sign divided by quantity. That is the per unit. Now remember, what happens when we divide by quantity, right? If we take total cost and divide it by quantity, we now have average total cost. That's total cost per unit. If we take variable cost and divide by quantity, we get variable cost per unit. If we divide total revenue by quantity, we get price. And price is the per unit revenue, right? So price is going to be represented over here on this graph. So over here, we're going to see things graphed like price. We're going to see things graphed like average total cost, average variable cost, that's supposed to be a V, average fixed cost. Two other variables that they're not divided by quantity, but they are per unit, meaning each unit of production has this number. And remember that marginal revenue is each unit has its own marginal revenue and marginal cost, because marginal means when you produce one more unit, right? Well, if we're counting per unit, that would be marginal revenue and marginal cost. So anytime you see graphs of total revenue, total cost, fixed cost, and variable cost, you're definitely looking at the total dollars graph. But if you see price, average total cost, marginal revenue, marginal cost, average variable cost, and average fixed cost curves graphed, you are looking at the per unit graph. This per unit graph is the graph that is used for the infamous supply and demand in economics. And we're going to get to that in Unit 2. So now that you understand the two types of graphs, here's what you need to understand. For break-even analysis, we can look at this one or this one. Both of these can show us break-even analysis. But the one we're going to look at today is the total dollars graph. We're not going to look at break-even analysis with the dollars per unit graph until Unit 3. Okay? So what we're about to do in just a few seconds is going to be done on the total dollars graph. All right, so let's go ahead and graph all the variables that we need. Now we know in dealing with break-even analysis, we have dealt in fixed costs, we have dealt in variable costs. We've also talked about total cost and total revenue, because that's what we broke down. Now, initially, what I want to remind you is that break-even occurs wherever total revenue is equal to total cost. Okay, so ultimately what we're going to do is we're going to look for a place on the coordinate plane where the total revenue curve intersects the total cost curve, because that is going to give us our break-even point. All right, so the first thing that I want to sketch on here, now understand these are just sketches. We're not getting specific right now. We can get specific later. Note, I do not have a grid, so we're not getting too specific. We're just doing general shapes. The first thing I want to draw is the fixed cost curve. Now, the fixed cost curve is interesting. It's different than the other ones because remember that fixed cost does not change as quantity increases. So, whether we're at a quantity of 0 or at a quantity of 20,000, fixed cost will be stable. It'll be the same. It'll be constant. And the graph of a constant number is a horizontal line. And so what we're going to do here is we are going to we're going to pick any arbitrary number. Let's use orange for fixed cost. So right here, we're going to call that fixed cost. Okay, and I'm going to get this level here, and I'm going to make sure that it's level, it's straight, so that it's constant. And what I'm going to do is right here is I'm going to draw a horizontal line, and that horizontal line is going to represent our fixed cost. I'll actually come over here and I'll put FC for fixed costs. I don't want it to get in the way over here. Okay, so that is the graph of fixed cost. Anytime you see a total dollars graph and you see a horizontal line, that is the fixed cost curve, because as quantity increases, fixed cost doesn't change at all. Now, let's now graph variable cost. Okay, and what we'll do is we'll graph variable cost, let's say in red. How does variable cost start out? When quantity is 0, what is variable cost? Well, if we produce 0 units, remember, variable cost changes with quantity, right? As quantity goes down, variable cost goes down. As quantity goes up, variable cost goes up. And therefore, at a quantity of 0, variable cost will also equal 0. So I'm going to put a dot right here, red dot right here. And we also know that as quantity increases, variable cost also increases. And so we're going to make an upward sloping line here. Now, here's what I need to warn you about something. In reality, these lines are not, except for fixed cost, these curves that we're putting, I call them curves even though they're straight lines, okay? Because in reality, these lines, variable cost is more likely to be curvy than it is to be straight. But just to get an understanding of what's happening with break-even analysis, we're going to use straight lines, okay? All right, so I'm going to go right here, and I'm going to draw a line upward sloping. Therefore, you can see as quantity increases, the total dollars of variable costs also increases. Higher quantity, higher variable cost. Lower quantity, lower variable cost. Okay? All right, so we've got fixed cost and variable costs. Now let's do total cost. Total cost is easy because total cost is variable cost plus fixed costs, right? Now, if we have fixed costs, will total cost equal 0 when quantity is 0? No. Remember, when quantity is 0, total cost is equal to fixed cost because variable costs are 0. So let me prove that to you right here. If we have total cost, we know that total cost is equal to variable cost plus fixed costs. Whoops. When quantity is 0, variable cost is 0. Therefore, total cost at a quantity of 0, that's a theta, that's not a 0. At a quantity of 0 is going to be equal to variable cost of 0 plus fixed cost. So, at a quantity of 0, total cost is equal to fixed cost. And therefore, we can start graphing our total cost, which we will graph in purple, I suppose. At a quantity of 0, total cost is equal to fixed cost, so it's going to start at the fixed cost line, at the height of fixed cost. Now here's the other interesting thing that I need you to remember, is that the thing that causes total cost to change is variable cost. So the slope, the increase of total cost, is going to be equal to the increase of variable cost. That means that the variable cost curve and the total cost curve are going to be parallel to each other. And I'll do the best that I can to get them to be parallel. I'm going to put this in here. I'm going to set it up here over on the left, and then I'm going to try to make it parallel to the variable cost curve, or variable cost line, I suppose. And now I'm going to draw a straight line here. And as you can see, that's pretty much parallel to the variable cost curve, and that is the total cost curve. So now we have fixed costs, we have variable costs, and we have total cost. And now we only have one graph left to draw, and we'll do that in blue, and that is the total revenue curve. Now here's what I want to remind you about the total revenue curve. First of all, if quantity is 0, what will total revenue be? Well, I want to remind you that total revenue is equal to price times quantity, right? If quantity is 0, 0 times price is 0, so total revenue will be 0. So at a quantity of 0, total revenue is also 0. So that means that total revenue is going to start out at the exact same place that variable cost started out. But here's the next thing I want to remind you. That the price, which is the per unit, right, must be greater than the average variable cost, okay? So here's what I'm pointing out. I mentioned this previously, that if the price is lower than the average variable cost, this business is in big trouble. That means if they sell one unit, they're automatically losing more and more and more money. So we know that in order for a business to be viable, the price it's selling for has to be higher than the average variable cost. So now what I'm going to do is mathematically I'm going to multiply both sides by quantity. And so price times quantity is total revenue greater than average variable cost times quantity is variable cost. And so what I'm saying here, that means is that total revenue must be higher than variable cost. What I mean by that is this: aside from starting at the same place, 0, from here on out, total revenue will need to be higher than variable cost for this business to stay viable. Therefore, we are not going to draw it on top of variable cost. We're not going to draw it below variable cost. We're going to draw it with a steeper slope than variable cost, and that means that it's going to have to be above variable cost. Okay? So what I'm going to do is I'm going to draw a line in here, a curve, representing total revenue, and the whole curve, except for this point down here, the whole curve will be above variable cost. And so let's go ahead and there's variable cost. Maybe we'll do it right about there so that it's above variable cost. So I've got here, I'm going to draw that line right there, and that blue line is going to represent total revenue, okay? And now we are ready to understand the break-even point of a firm. Once you understand all these graphs, you can now very clearly see it. Some of you have already seen it, but if you haven't seen it yet, I'm about to show you, okay? So here's the deal. Break-even occurs where total revenue is equal to total cost. And that means that total revenue, the total revenue curve, needs to be equal to the total cost curve, and mathematically that means that they are intersecting. And total revenue and total cost intersect right here. And now what we would do is from that point, we can go vertically. We can draw a vertical line down here to the quantity axis, and that quantity becomes our break-even quantity. And then we can draw a horizontal line from that point over to the vertical line, and that becomes our break-even total revenue, which, by the way, is also the break-even total cost, but we do it in terms of total revenue, not total cost, because they're both of those numbers are equal. And so now this vertical height, this dollars, represents how many dollars the company needs to break even, and this horizontal quantity represents how much quantity. And that point right there, this point is represented as quantity, comma, dollars. It is the break-even point represented as both quantity and dollars in terms of how much must be produced and how much must be earned in order for this business to earn zero profit. Okay? Now, a couple other things I want to point out here. if you look here, this wedge right here. I want to explain this wedge. I do have another color. Let me grab this color right here. Here's green. So, do you see the difference between total revenue and total cost? This vertical difference here. Remember that profit is equal to total revenue minus total cost. Well, leading up to this quantity and this dollar amount, total cost is above. So all the way up to here, total cost is greater than total revenue. Therefore, this number is smaller. So this number minus this number is going to be a negative number, okay? And that means that this region right here, this triangle, leading up to the break-even point between total revenue and total cost, that region represents where the business is operating at a loss. Okay, this triangle represents loss for the business. And if you were to add up all this money, it would show you how, well, actually, all you have to do is do the top number minus the bottom number. That tells you how much loss the company is experiencing. And look what happens as we get closer to the break-even point. This distance is getting smaller and smaller and smaller, and therefore the loss is getting smaller and smaller and smaller until the loss is zero because the company is breaking even. But when we get past the break-even point, over here, total revenue is greater than total cost. And therefore this region, each one of these vertical lines as we go, represents the profit of the firm. And as you can see, the profit is getting larger and larger and larger as the quantity increases. Now, that's not entirely accurate. What we're going to see later in the semester, like I said, the total revenue curve is actually not a straight line. It's actually a curve. What happens is the total revenue curve actually starts going up, and then eventually it peaks out, and then it goes downward sloping. Okay, and so that's what we're going to see later in the semester. But for now, what you're looking at here, here's what you need to understand for this particular lesson and for the quiz. You need to understand what all the graphs look like. I can give them to you and not give you the labels, and then you have to try and know. You have to know which one is which. You have to know that this region is the region of loss because total cost is greater than total revenue. You have to know that this region is the region of profit because total revenue is greater than total cost. You have to know that this point is the break-even point, and that this represents the break-even quantity, and that this represents the break-even total revenue. Okay. All right, well, that's it for break-even analysis, and you are really building up your microeconomics knowledge. And in our next lesson, we're going to move on to some really cool stuff. We're going to talk about the short run and the long run, and a great concept called the principal agent problem.